This is our spring training session, Integrated Compliance Checks, which is about adding constraints and checking item suitability. We have a particular focus as well on some new tools that are available. We're going to make sure people are introduced to, but also for those people who aren't using suitability checking yet, just a little bit of background and a little bit of orientation as well. So what we'll cover today is a very brief suitability constraints overview, an introduction to the new reporting options in suitability check, and then sort of like a bit of a demonstration of suitability checking and those reporting options, and reviewing that format, which includes the new information, and just a little bit of a highlight of where suitability checks can be used and tips on adding suitability constraints. So what is a suitability constraint? Fundamentally, it is a rule or a compliance check that can apply to business scenarios, and those business scenarios can include a region, so whether it's US, UK, EU, for example, customers, specific customers, as well as groups of customers, even suppliers or your own business. And they help adherence to policies and regulations, so it could be hard and fast regulations that you must not do this for a particular application, for example, or even customer policies. And that could be ingredient limits or final product labelling, and lots and lots of things that you can make a compliance check around. So they're used by applying them to either types of items, so it could be flavours or fragrances, because they would have different sets of rules, but also to different consumer applications. So if you're a flavour company and you've got a flavour for dairy, it's going to have a different set of constraints probably than if it was for drinks, because there's different rules that the environment that you're operating in might have for those things. And similarly for fine fragrance or foam bath, you have different sets of constraints maybe apply. Now, when a suitability check is triggered in the system, the item is checked against all the relevant rules and a suitability report is generated. We'll see that. And these checks can be done during product development or selection, and can also be linked to projects and used during document generation. So it is a real product lifecycle management sort of tool. And the key benefit is to ensure that formulations comply with regulations and customer policies during creation and through the product lifecycle. So it's an ongoing compliance tool. This is an example of a screen from software, which is showing a suitability check and its results. So here's an item, a formulation that's a flavour, and a company has been entered. This is a customer, this is a fussy customer, because we all know what those are like. And we haven't entered an application, and actually parties or customers and applications, they're optional to add to this screen. If you didn't add a party and just pressed suitability, to check the suitability for an item, it would faithfully do it, and it would use any of the global constraints that you've added. So global constraints could be that your company as a business chooses not to use certain ingredients above a certain percentage, or may require certain other things to be true. So maybe you don't want to submit formulations if they have a particular hazard classification. So that would be an example of a global check. But you can optionally add in customers and applications, so you can add in more than one. And then here are the new reporting options that we'll come on to. So and this particular one has a failure because it's got a red cross. So I'm going to just do that in the software live so you can see it. So this is that same check that was on the screen. And if I press check suitability, see it comes up with that cross. We can click on it and then we can view the details. So if we view the details, the suitability check report is generated. This is a simple one, it's only 2 pages long. And so it's our fussy customer has some linkages behind it. We're not going to go into the detail of that, but there's reasons for that. And the check has found that there's a violating component. And in this case, diacetyl is forbidden. You can kind of see that here. And diacetyl is present in the whole formulation at 0.04%. And you're allowed 0 because forbidden is 0. And where diacetyl is in terms of the structure of the formulation is it's present in a solution of diacetyl. So diacetyl 10% in mpg. So you get feedback on which component is a problem, where that appears in the structure. And this is the first part of the report, dependent on which of the options you have ticked. So if you didn't have this option ticked to show the violating components, you wouldn't see this piece. And there is another section, which is the which suitability checks are actually failing. So here's the components, and here is the check that is failing. So because there's only one, it looks a bit repetitious, but in an example that we'll look at later, you can see more clearly what the difference is. And also because we tick the box, it's also got the suitability constraints conformed. And so this feedback as these other checks that have been done for this formulation based on you pressing that check suitability button. And so these are the new options, these report options to include violating components. So obviously that was the bit we just saw where diacetyl was being called out, and then include the violating components structure. That was the bit that showed that diacetyl was present at 10% in mpg. And obviously then we saw as well that the conformed constraints in suitability check report were also shown. They were all the things with the ticks to say that they passed. And what we didn't see is the include item sources structure report in suitability check report. That is an expanded view of the composition, the whole formulation, where it shows where all of the components are found in which item. So it depending on the complexity of your formulations, it could be quite a long report. So how you configure which things are ticked and which things are not is in manage application settings. So again, so for people who are using suitability checking and you want to take advantage of these new options, you would go to manage application settings and set your criteria such that if you say anything that says no doesn't appear, but then with the options around yes, you have yes that it appears and it's greyed out, means you can't untick it. If you say yes and it's a prompt, then you can untick it. So in the example that we're using, we have yes as a prompt so that we can untick them if we want to. You can also have no as a prompt, in which case it appears unticked, and then you can obviously tick it if there's a particular circumstance that you need to show it. The benefit of this level of configuration is in a company using suitability checking, in any given scenario, one or more of these things are useful, but you probably don't want them all of the time for every user. So this gives you some functionality that means you can really configure how you present information to your users, and also that they can interact with it themselves. So the idea is to set your default scenario up to please most people most of the time and give them the facility to tick and untick dependent on what they need to do. So just as a sort of overview of those things, include violating components is there to call out which is the component that is the problem. And you can either have that on or off. We've got it on in our example. The structure of the violating components you can have on or off. So we saw that with diacetyl. Another example would be something, say, like estragol, whereas with the diacetyl example, because it was then in diacetyl 10% mpg, it wouldn't have taken a genius to work out where the diacetyl was. But with some other components, it's a bit trickier. So estragol is another example. And so in this scenario, it might show that estragol is the violating component, and it would then declare that it's present in, for example, basil oil, which contributes 0.18%, and in aniseed oil contributing 0.02%. So it's really helpful when you're using natural materials and you've got components in natural materials that are a problem. Also useful if you use bases, which I know is more common in fragrances than it is in flavours, but useful nonetheless. And then the maximum concentration for violating components, we haven't seen an example of that yet, but we will. But it's as the title suggests. And if instead of a prohibition, there was a limit, so for example, if the rule for estragol was to limit it to 0.1%, then that would be shown if this box was ticked. So it might show that estragol is 0.2% and the maximum is 0.1. So in that scenario, you could see all of those things, and it would then give you information to know how easy it was to modify, and then give a bit of insight into what you might want to do to modify for sort of like for flavorists and perfumers. Now, some scenarios are trickier, and we do look at a few of those in a little while. We also have the option to include the conformed constraints, and so we saw that for some companies, the scenarios in which they operate are so complex, they end up with a very long list of conformed constraints. And when people are comfortable with how they've set up suitability, typically people don't need to see these. In the early days, when you're trying to set up your suitability, and maybe some customers have got checks and other customers haven't, and maybe you start with your highest value checks and most complex customers that slow you down, that might be where you start your suitability check journey. And there might then still be some customers that don't yet have any checks. So at that stage, knowing whether something's being checked or not is helpful, because if you just get a green tick but nothing was checked, you kind of want that feedback. So in the early stages, showing them can be helpful, but often as people become more and more comfortable with suitability checking, they may choose to turn this off. And then the other thing that we talked about briefly was the item sources structure report. This is the long form composition report showing the entire structure, and it doesn't just relate to failing components. So it is the whole composition of the formulation shown in a component view, so that you can find where problem materials are throughout. So it's an alternative way of looking at information. Typically, if people have the violating component structure on, they may be less interested in this, but it does depend. There's some preference involved. So we're going to look at some more scenarios. And just as an additional context, suitability checking is set up relating to the environment a company works within. So this can include global regions and the client base. And because that's so diverse, as well as if you factor in the applications, it's necessarily very configurable. And within that, there is some knowledge that's required to really be able to navigate suitability checking effectively. The good thing about it, sometimes people are a bit nervous about it, but the good thing about it is you can set up a check and you can see what the effect is immediately. So you get to know whether what you've done is right. And so it is an area where you do need to set something up and then test it to make sure that you're getting the result that you would expect. And like I say, don't be afraid of it, but we're here to help as well, because that initial setup and configuration, there's ways of doing it that make it easier to manage on an ongoing basis. So please do ask questions in the chat, and if they are too complex to cover in appropriate detail during this session, or at the end when we will allow some time for questions, we can arrange separate follow-up. So this is an example that we're going to look at, and this is now a fragrance example where it's the same customer, different formulation and different applications, and we're going to use the same settings with those report options as our initial view. Back to our suitability checking screen. Our formulation, obviously you can put it in with the name or the code, as you know, and we're going to go roll-on antiperspirant at 5%, which I know is too high compared to the normal. But So we can just get some nice failures. Nice failures, that's a bit of an oxymoron, isn't it? Okay, so if we check the suitability, when it's performing this function, whenever there's a dilution aspect to it, it's not just looking at the formulation and saying, does it work? It's having to look at the formulation, calculate if some of the things that are present in the fragrance as such, how much is present when you dilute it. So obviously 100% of something is different to 5% of something. So that's why it takes a little time, because it's doing quite a lot of calculation work. So it's exploding the formulation, looking at the compliance and the rules to then determine this answer and ensure that information is available to populate this report. So when we have entered this information, there's expanded parties and expanded applications. I won't go into it too much, apart from to say these relationships are quite important for ongoing management and can help suitability checking become easier to manage. And also, this is our test system, so not all of the data is good data, but it's fine for this demonstration, but it's not all 100% accurate and good and wholesome. So in this failure, we're looking at the 5% dosage, and we've got a few different types of failures, and obviously now we've got a bit of a longer report. We've got a 5-page report, and our first violating component is alpha-pinene. We've got 0.079035%, and some of that is coming from bergamot, and some is coming from ginger, some's coming from lemon, and so on. So you can see that we have the structure of where alpha-pinene appears in this composition. And the reason it's failing is it has an allergen, that too many allergens effectively. This is an overcount condition. And again, there's additional explanations of what these criteria mean within the help centre of the application, as well as, we've got other documentation available. But they're in this customer says that you're only allowed one. You're allowed a maximum of one allergen in application, and you've actually got 7. So you've got 7 allergens, you're only allowed one, and you have this limit here. This is the limit at which the allergens end up being required to be labelled. And this is how the system is counting. So it's calculated at a 5% dosage based on these criteria. You're going to end up with 7 that need labelling, and you're only allowed one. So it's telling you where each one of those are. If we scroll down, we can see other allergens as well. So the other 6 should be here, and then indeed they are. So it's telling you where they all are. Now, there's another failure here, a different type of failure for a different component, which is on the cyclopentadecanolyde, where it's not meeting the IFRA requirement. So IFRA is a safety style regulation where certain ingredients have to be used below a certain percentage in order for safety to be considered correct. And in this circumstance, there is 4.21% of this material in the formulation, and the maximum you're allowed is 2.599. So there's too much, and it's given a very clear instruction there. So you have to reduce this to this below this amount. With the allergens, you have to get the 7 that you've got down to 1. That would be how you would make this comply. Obviously, the system can't tell you which one to pick. That's very much a developer decision. And so these others scroll down a bit further, and then we get to the second. Now, the second part of the report is the suitability constraints violated. So the top part was components and the structure, and some information about how much and when it's possible, how much you need to reduce it to. So it depends on the type of constraint as to the information you get given. This is the view the other way around, which is, okay, which criteria are failing and which are the materials that are failing because of the criteria. So at the top, we have which components are failing and what criteria, and the structure. And then in this section, which criteria are failing and which components are the problem. So that's why we have now the IFRA problem and the material that's responsible there. And then we have the allergen problem and the allergens that are appearing. And then we've also got the suitability constraints conformed. So at this dosage, it was 7 allergens and an IFRA problem. If we look at the second report, and I've done them deliberately separately so we can look at them side by side if we need to. You can do them together. We now have only 6, so it's dropped by 1. That reduction in dosage has meant that one of the allergens is now under that radar of you have to be labelled on pack. So now we've got 6 that are a problem. So we've lost 1 by that reduction in dosage. We've also lost the other hazard for IFRA. That IFRA hazard no longer appears. And if we go down to the constraints violated, you can see that now it's only the allergens, whereas previously we also had the IFRA problem. So it's the same customer, same application, same fragrance, different dosage. So you can see this sort of like highlights how quickly the system is able to assess the impact of the maths. Fundamentally, this is impact of maths. So 2 constraints violated when it's 5%, only 1 violated when it's 1%. But that makes sense for people. So I have another example. So now, excuse me, same item, same party, different applications. 2 different dosages, and in this example we have 1 that fails and 1 that passes. So again, you can see the impact of the dosage can genuinely impact the pass and fail, as can the application itself. I'll just change these. Again, it does that, explodes out the formulation and then calculates what is the impact of the dosage on the constraints. For a passing one, see now, if we hadn't included the suitability constraints conformed, it would be a 1-page report because everything has conformed. And if we look at the failed one, we start to see some interesting results. Again, so we've got beta-pinene is failing. Now, see, previously it failed because it was an allergen, but that allergen labelling related to the cosmetic regulation, and a reed diffuser isn't a cosmetic, so it's no longer failing for that reason. It's actually failing for a different reason. And this particular customer doesn't want the dead fish, dead tree label on pack. So this is what this has been configured to do. So they don't want dead fish, dead tree label on the reed diffuser consumer pack, and this would occur in this situation. So at 30% dosage for reed diffuser, you would get that. And this is now expressing that information. So the IS code relates to the environmentally hazardous chronic 2 limit, which is the one that drives the dead fish, dead tree. And it's showing you that beta-pinene is a problem component and where it appears. So again, it's appearing in the same place as it was before, the bergamot, the ginger, the lemon, etc. And it shows you the spread of where that is. So of that 0.34%, a whole lot of it's coming from bergamot. Smaller amounts are coming from other places, but most of it's coming from the bergamot. And the EHC2, that environmentally hazardous element, this is a cumulative limit. So this is now quite a tricky thing to wrap your head around, because all of that environmental hazard is driven by all of the environmentally hazardous components in a formulation, and all of them contribute together to make the dead fish, dead tree label. So that's why it's then expressing it as a percentage of the limit. And I know the people who are used to doing suitability constraints, this makes complete sense. And I hope that I'm not losing other people who are not so familiar with it yet. You are allowed up to 1 effectively. So you're just under the limit because at 1, the label occurs. So this component is contributing 4% of the overall limit that you're allowed. If we scroll down to a different example, hopefully it starts to make more sense. So you've got here, you've got D-limonene that's in orange oil is actually contributing 59% of the limit. So the reason it's failing is because you're over the limit. And this is why when you look at these percentages here, it adds up to more than 100 because you're over the limit. But also, this is relating to how much this individual item is contributing to the target where you can't exceed the target. So the higher the percentage here, these are the ones that are the most problematic for this failure. So from a perfumery point of view, you would need to be looking at reducing the quantities of your D-limonene, ISO, and ISO-E because of how much it's contributing. And there's another one that's a biggie as well, which is galaxolide. Now, to run the numbers in your head is quite tricky. As you get familiar with it, these numbers really, really help. They help the perfumer to target which materials by how much in order that they can achieve a compliant product. There's another example that's a little bit easier, which is the skin sensitizer example. The reason the skin sensitizer example is easier, even though it's phrased very similarly, is because sensitizers are not cumulative. So a skin sensitizer, to avoid a skin sensitizer label on the product, which is also what the customer is trying to do for their final product, each one of them has to be below the limit. So for this one, D-limonene, from a skin sensitizer point of view, it is in application, it would be 1.749%, and it needs to get to below 0.99% in application. So that's a slightly different way of a different thing to work with because it's non-cumulative, whereas the environmental is cumulative. So then the other way around, looking at the information the other way around, you can see that the property maximum for the skin sensitization is 0.99 limit, and the highest one that you've got is 0.74. This is the highest one because it's non-cumulative, and you can actually see that this number here relates to the ISO-E. So the ISO-E is the worst offender, but you can see that there are others. So you can see that there are others that are over 0.99, and any one of them on their own would then be a problem. So this one here, the muscarone, is just at the level at which it won't be a problem on its own. So you've got to get all of these below that 0.999 limit in application. And then the environmental one is 0.99 again as its limit, but it's cumulative, and you've got too much, and each of these are added together. So the combination of all of these reach this number, and so altogether these have to get to below 0.999. So that's then feeds back into those percentages in the first part of the report that tell you which ones are the biggest contributors as a percentage of the whole picture. So, where can suitability checks be used? It's kind of throughout the software, because compliance is obviously such a big part of the work that people do who use Formpak. Compliance is therefore throughout. So a key place it's used is during the formulation development stage. So in the CDT, while you're formulating, you can perform a suitability check. So I was doing it directly from the menu during that demo, but during formulation development, you can actually perform that check. And that means that before you even save your formulation, you know it's compliant. Before you send it to the lab, you know it's compliant. But you can also use it when selecting from your product catalogue library. So, for example, in fine matching items, you can use it in baskets. So you can collect items together and then check the contents of your basket, which is a bunch of items. And you can also use it directly from viewer formulation and viewer raw material. During project work as well, you can use it, and this is where we're finding it's getting a lot of use. That's quite new use because more and more people are using projects in Formpak now. So in your tasks, you can have background checks. So at the point at which you've been working on a task, you've said these are the formulations I want to submit to the customer, for example, and then you change your task to say, okay, to say it's finished, I've finished my task, there's a background check that will say, okay, you thought you had, but maybe you haven't because these don't comply. So there's lots of integrated checks that you can add into the software. And also when you're printing documents and labels, you can, because see, when you create formulations, you create them to be compliant, but do they stay compliant through the life cycle? That's quite a tricky one because you don't always know what your customers are doing actively, and a point at which you interact with what your customers are doing is when you're sending out samples later on, which comes back to the tasks point of view. You can put them in there, but also when you're printing documents. So if you're asked for a safety data sheet or some other kind of status document, could be an IFRA certificate, could be a flavour specification, you can integrate suitability checks to make sure that at the point you generate that document, you also check, is it suitable for the customer at that point in time? And that can be a flag to alert you that something has changed about either the customer's rules or, more typically, the materials that you're using. So it could be that the hazards of something has changed or a regulation has changed. So you can use that integrated suitability check during printing documents and labels to help you sort of stay on top of things in terms of ongoing compliance. So lots of ways to use that. Now, when you come to add your own suitability checks to your system, the trickiest part is articulating what you want to do. Simple things are typically easy. For example, limiting a component or an ingredient to a specified percentage in the product itself or an application. That's fairly straightforward. But other constraints are trickier. For example, to avoid the dead fish, dead tree symbol on a consumer pack. So our top tips are to use an existing constraint as a guide and use the copy function, and phone a friend. You can ask us. We're happy to help. We do need a clear articulation of the requirement, and that's not as easy as it sounds. And we understand that because sometimes customers will describe what they want to achieve, and it's not, the words sound, you understand the individual words, and as a sentence, it makes sense. But what does it precisely mean, almost from a mathematical point of view, is quite hard to then articulate. So we understand that that's a bit of a challenge. But that is in some ways, the trickiest part is the articulation of the requirement. So we're going to just show you a couple of examples around that side of things, and then we can go on to questions in a few minutes. So managed suitability constraints is where the suitability constraints are added and managed and viewed. And so if we look for the customer that we've been using through this session and search, you can see these are the checks that are associated with this customer. I said it's not particularly clean, but these are the ones that are there. So what we could do, we could look at a material that has a limit and maybe copy it. So for example, we've got a limit on camphor. If we view that constraint, you can see we've now got a copy button. So I'm going to say copy the constraint. I'm going to say I'm going to limit estragol instead. So I'm going to call it a different thing. These comments are really helpful because at the point you're adding the constraint, you know what you're trying to achieve. So by adding a comment that reflects what you're trying to achieve, you're able to later on follow that that's what it was about, and it genuinely helps you. So really encourage you to use comments that describe what you're doing. So then I'm going to, and you can see here, there's different types of conditions, and this is the right one in this circumstance. We'll look at another one in a minute, but it's a regulatory item limit. You could have a physical item limit. So a regulatory item limit is obviously about what's inside your raw materials. Physical limits are about the physical products themselves. So an example where normally for regulations, it's about regulatory items, but sometimes it's about physical. An example of where physical is the right approach are things like kosher, halal, organic. So they are things that genuinely apply to the raw material that you buy, but often it's regulatory. So we're going to put in our estragol. We've got loads of them just because it's a test system, but typically on your system you'd only have one. And we're going to change this limit. So we're going to say, okay, it's 0.1. And here we've got this in application. Does it relate to the application limit? Are we trying to, in the customer's application, limit it? Or does it actually relate to the product we sell? So if it's the product we sell, it's not an in application limit. So I've changed it a little bit, but started from an existing one. So now this means if there was a product with estragol in, and we were selling it to this customer, it would enforce that estragol had to be below 0.01% in the formulation. That's what we've just done there. So let's save that. And now that exists. And you've also got, you can add a similar suitability constraint. So we've obviously got the copy, but we've also, if you were having to do a few in a round, you can add a similar one. So let's do that. Just add a similar one. It's basically the same as copy, but we've just done it in a different way. And so we'll still do it for estragol, and let's do it for pulegone. And let's do the same as well. We're just saying it's a 0.01% of pulegone. But again, you can do that in application. So if I search again, those new ones come up. Oh, I didn't change my comment. Let me do that because that'll drive me bonkers. Okay. It's the kind of person I am. That kind of thing drives me bonkers. Okay. So there we go. Search again. Okay, so now we've got limited pulegone, limited estragol. So we can also see some other types of examples here. So we've got a property minimum. This is a useful one. So if you need to say that something must be above something, you use a property minimum. This is obviously on a flash point. And for candles, because it's been made that it's application related, if it's a candle, the minimum flash point must be 61. So you can see how you can configure different checks that are very, very sensitive to specific situations. Now, we also have, just going to find my here. So this was one of the limits we looked at that we tripped across when we were doing our suitability check. We had this property maximum for skin sensitization in application. So let's have a quick look at that. So the skin sensitization hazard, this is the way it is structured, has to be below 1, which is why it's at 0.9999 in application. That was the check that was saying you've got too much skin sensitizers, and each of them had to be below that 0.999 level. If we copy the constraint, we could apply that to a different type of hazard. So for example, and with this scenario, we don't have time to go into the full details why, but in this scenario, you're always targeting these equals ones, and it's because they're the percentage limit overall. And so it takes into account whether it's cumulative or whether it's non-cumulative. So let's say that we wanted to make sure our eye damage corrosive here, this eye damage irritation category 1 was also not on pack. We would select this and say, okay, we do not want that corrosive symbol for eye damage to be on pack. And by copying that initial, that first constraint, we can achieve that by that. Thanks very much for joining today.